Alright, next thing, vector-wise, we're going to talk about what are called resultants. Okay? Resultants are sums of two or more vectors acting at once. Sum of two or more vectors acting at once. Okay? For example, you could think about it this way. If I were to apply a force pushing this directly towards that wall, well, Anna applies a force pushing it directly towards this wall, what's going to happen? It's going to move kind of diagonally, right? Depending on the amount of force each one of us is putting on it, but it's definitely not going to go straight that way. It's definitely not going to go straight that way. It's going to move at a little bit more of a diagonal. That diagonal is the resultant. It's what will happen when two or more forces are acting on an object at the same time. Okay? It would be the sum of my force with the sum of her force acting on it at the same moment in time. Okay? So we're going to find some resultants by adding two or more vectors together. Okay? Alright, I'm going to show you a couple ways to do this. Okay? Here's our situation. Let's say we have a river. It has a current of 2 meters per second to the south. Okay? You're going to try and swim due west across the river at 5 meters per second. Okay? What is your resulting velocity and direction? Okay? Well, clearly you're not going to end up swimming straight west, right?
No.
If you try to, while the river's pushing you, okay, you're going to end up a little bit downstream. Make sense? Okay? There's a couple ways to do this. One is by simply adding two vectors together. We're going to draw a vector that represents the current. A vector that represents the current would be a vector that looks something like this. 2 meters per second. And I could write that as an ordered pair. What are the horizontal and vertical components of that vector? 0, negative 2. Yep, because it's 2 meters per second. Yep. Okay, so this is what the current is doing. And we're going to add on what the swimmer's trying to do. Swimmer's trying to do what?
Go west at 5.
Swim due west at 5, so I'm going to draw that person's vector. How could I write that as an ordered pair? Negative 5, 0. Good. And if I want to know the resultant of those two vectors acting at the same time, okay, a resultant, remember, is just a sum. So I'm just going to add them together. 0, negative 2 plus negative 5, 0. I add the x's, I add the y's, and I get
negative 5, negative 2.
Negative 5, negative 2. This is my resultant as an ordered pair, as an x and a y. But I want a resulting velocity and direction. So what I'm going to do is I'm just going to take this xy, draw the picture, negative 5, negative 2. Find my magnitude using Pythagorean's theorem. Find my direction using inverse tangent. So my magnitude, 25 plus 4 is 29, so the square root of 29, or about 5.4. Okay? Square root of 29, or about 5.4. So my resultant velocity is 5.4 meters per second. At, somebody, an inverse tangent of 2 over 5. Inverse tangent, 2 over 5. 21.8 degrees. What? 21.8 degrees. What? South of west. Okay?
So how do we know, like, if it's not, how do we know that it's southwest and not west of south?
Sure. Okay? Question is, how do we know if it's not west of south or south of west? Okay? When we did the inverse tangent of 2/5, that would help me find this angle right here. Okay? That angle is how many degrees away from west?
Okay.
21.8 degrees. And in which direction of west? Well, it's 21.8 degrees south of west. Okay? Most of the time you're probably going to find that reference angle, which is nearest the x-axis, so your answers will be south of west, north of west, south of east, north of east is probably how you're going to answer a lot of it. Does that help?
Yeah.
Okay? Alright. Another way to do it would just be simply to make the picture itself. Okay? So here's my river. I'm going to try to swim across the river at 5 meters per second. While I'm doing that, the current is going to push me south at 2 meters per second. If you make the triangle, this blue arrow here, that is my resultant. Notice the triangle ends up being the same as this. Okay? For this problem, this is very simple because it's a right triangle. But if I say, I started out swimming 20 degrees north of west at this many meters per second, okay, then your picture is not going to involve right triangles anymore. You can still do it using the picture method, but you'll end up using a lot of law of sines and cosines. Okay? It's totally fine, but I'm guessing most of you will just draw the picture separately, find the x and y's, add them together, and then find your magnitude and direction. John?
It's like closer to the y-axis, that make more sense to go from west of south.
Yeah, it honestly doesn't matter. You know, if you answer this question and you say this is 68.2 degrees west of south, good by me. It's the same thing.
Yeah.
68.2 degrees west of south is exactly the same location as 21.8 degrees south of west. You with me on that?
Yeah.
So, it doesn't matter. But I'm saying most of the time when you draw your pictures, don't you usually put your reference angle nearest to the x-axis?
Yeah.
Okay. Yeah, you don't have to when we're dealing with story problems, but a lot of times you would. Okay?
It's still
They
extremely.
found out that the swimmer will be swimming at like 11 point some miles per
Which is
hour with
world record pace. 5.05 is the fastest recorded ever, so.
Okay.
I mean, that's a pretty fast swimmer.
That
You're
is.
being recorded.
Alright, so, questions on that? In order to add vectors together, all you do, add the x's, add the y's. In order to subtract them, subtract the x's, subtract the y's. Okay? If, let's say it's early in the year and the current is 4 times faster than what it is right now. That'd just be like multiplying this vector by 4. So what would our new current be? 0, -8. Okay? If it's 4 times longer, it's just like multiplying by a scalar. Alright? 4 times 0, 4 times -2. So my new vector would be 0, -8. But you'll do a few things now with some adding and subtracting of vectors. Just some basic things. We'll get into more story problems tomorrow. Okay? Try problem number 8.